diffraction of light waves through an aperture. In our earlier session, we have learnt about diffraction. Now let us learn how the light waves get diffracted at an aperture. According to definition, the bending of a wave or its deviation from the original direction of propagation when it meets a small obstacle is called diffraction. The wavelength of the light waves is 5000 angstrom, which is very less compared to the wavelength of the water waves and sound waves, which are about few centimeters to meters. As the wavelength of the visible light is small, comparing to the wavelength of the incident waves. Hence, for experimental observation, diffraction of light waves needs small-sized obstacles. As we learnt earlier, according to rectilinear propagation of light, when light falls on the opaque object, geometrical shadows of small opaque objects should be formed. But as the obstacles are small, the light wave bends along the corners of the obstacles and slightly spread into shadows, and thus they are not sharply defined. In the case of monochromatic light, when the light wave is incident on the small object like hair or a sharp edge object like blade, due to the geometrical shadows are formed with dark and bright fringes. Thus, diffraction is defined as the bending of light waves around an obstacle whose dimensions is comparable to the wavelength of the incident light, and hence its spreading into the geometrical shadow.